All right, chapter 9. This is one of my favorite chapters in the book. There's a lot of cool stuff in here. I'm going to start to pull some cool things together that come from similar triangles, which of course we just talked about. So here's an opener. Again, you can do this on your own. I'll have more posted with my solution sheet. You should get an answer of 4 root 6 for this problem. So a quick refresher here on simplifying radicals. We talked about this before, and I mentioned this just the other day. Remember, biggest perfect square. When I say perfect squares, of course, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49. This list, of course, goes on forever, right? Biggest perfect square that divides evenly into 24 is 4, 6 times. That square root of 4 is a perfect square. It comes out as 2, so that's why that becomes 2 root 6. Okay? If you're not good at this, don't hesitate to come in. We can talk about it. The biggest perfect square that goes into 32 is 16 2 times. So that would be 4 root 2. Okay, this, of course, is 25 6 times, 5 root 6. Now, I want you to realize, like this one here, a lot of times people say, oh, that's 9 times 8. Okay, that's true. Remember, you're not done. There's still perfect squares inside this 8. 4 times 2. This square root of 4 comes out as 2, turns that 3 into 6. It would have been quicker if you found the biggest perfect square that goes into 72, which of course is 36. You would have just gone immediately to this answer then. When you're adding or subtracting, you can only add and you can only combine like terms. So this would be 6 root 3 plus 6 root 5. I hope that rings a bell. Don't be the bonehead here who looks at this and says, oh, they're not like terms. You have to simplify them first. You see this, I'm going to do a shorthand version. This becomes 3 root 2. This becomes 6 root 2. This becomes 5 root 3. Combine like terms. These two are like, so you get 9 root 2 plus 5 root 3. Okay. You can do this last one yourself. Simple. We're not going to worry about negative powers. Don't worry about that. You'll do that next year. So here, when you have a fraction, that's the same thing as square root of 7 over the square root of 32. Square root of 32 is 4 root 2. Then remember, you can't leave a square root in the denominator. We talked about this in the beginning of the year, so you have to rationalize it. So you get root 14 over plain old 8. Remember, root 2 times root 2 is plain 2, because root 2 times root 2 is root 4. Square root of 4 is 2, and 2 times 4 is 8. Okay, this is cube root. Biggest perfect cube that goes into 16 is 8. So this would be 2 cube root of 2, but I wouldn't worry about that. This you should be able to handle. Again, rationalize. You get 28 root 2 over 10, because root 2 times root 2 is plain 2. Don't forget to reduce your fraction. Okay, next side, next page. So I'm not going to do this entire document, but I am going to do this most of the second page. If the altitude is drawn to the hypotenuse of a right triangle, so this is a right triangle. Sorry, it should have been indicated up there that is a right angle. Well, see, that's probably why I wasn't there. It disappears. Who knows? Anyway, that's a right. Just doesn't want to stick. Anyway, that's supposed to be a right angle up there, okay? Now, what you realize if you take your time, and I did this on another document recently, you have 3 right triangles there. They are all similar. The triangle on the left, ADC, is similar to the big triangle. Angle A is reflexive, and they both have right angles, right? So you can say ACB. And then that is similar to the one on the right, which is CDB. Okay. And sorry about the phone ringing there. We can set up proportions now based on that. This is what you gotta watch this. Identify the mean proportional relationships. So check this out here. So we have, let me change colors. We have AC in this and here, right? Watch this. I'm going to say AD matches up to AC. Okay? So AD is to AC. As this AC on the bottom is to this thing, AB. You see, that's a mean proportional. See, AC's twice. Okay? And then we can do even more with that. You see how BC is written here and here, and you see how DC is written in this one and in this one. I'm not going to go through all the details, but you end up, if you match up, well, let me do let me do the BA. So this is to this, okay, as this is to this. And then there's one, see, the BC is the mean proportional because it's the same. And then there's also one more at the end, comparing these two triangles. Don't worry, I'm going to tie this all together in just a moment. Okay. So, check this out. So down here, I'm going to do some cool things here. Considering that this is all terminology based in the big triangle. So that's the hypotenuse of the big triangle. This is a leg of the big triangle. This is a leg of the big triangle. That's the altitude. This hypotenuse, this altitude cuts the hypotenuse into two parts. Okay? And this leads to two equations. Now look at this. See this AC here? That AC is a leg. And if I cross multiply, watch that, I get AC squared equals this times this, AD times AB. Now look at this, okay? AC in the big triangle is a leg. AD is a part, it's the part next to the leg, and AB is the whole hypotenuse. That leads to a formula here. Leg squared equals the adjacent part times the whole hypotenuse. See, it also works here. Watch this. See, BC is a leg as well. See, watch that. Look at that. BC squared equals DB. There's the adjacent part times BA, which is the whole hypotenuse. And this one's different, but this gives us a second equation. Watch this. When you this DC, that's the altitude. And when that equals what? AD times DB. Well, that's part 1 times part 2. It doesn't matter which part you call 1, which part you call 2. These are huge. Instead of spending the time up here, instead of spending the time up here matching up these triangles, okay, and figuring out the relationships, this is just so much quicker. Leg squared equals adjacent part times the whole. Altitude squared equals part 1 times part 2. it can really make life a little bit easier. Excuse me. So here, I'm going to do a couple quick ones just to show you how to use it. So, this is supposed to be given to you as being an altitude, so I'm going to mark that in there. So clearly x is in the altitude position. So x squared equals part 1 times part 2, so 4 times 5. So x squared equals 20. So x would be 2 root 5. You got to simplify. Remember, we don't give the negative answer because that wouldn't make sense here. The y is in the leg position. Now, it's easy to mess this up. Leg squared equals the adjacent part times the whole thing, which would be 9, the whole hypotenuse. It's so easy to say 4 times 5. Be careful with that. So y, that's going to be 36, so y is just going to be 6. And then z squared would equal the adjacent part times the hypotenuse. So z squared equals 45, and that would be 3 root 5. It is so easy, so much easier instead of matching up those triangles. This is the way to go. Watch this. CD is 8. That's the altitude. BD is 16. Find AD. So 8 squared equals 16x. So x clearly equals 4. Okay. I'm going to erase that. And I'm going to do the other one. AC, I'm going to call that y. AD is 3. BD is 24. So leg squared equals 3 times the whole thing, which is 27. 27 times 3 is 81. Okay. So all I'm going to do now is just start this problem, and then you guys can finish a sheet and look at my answer key, okay? Excuse me. So BOX is a right angle, 90 degrees. Got this disappearing ink again. That's an altitude. BO is 3 root 2. Again, picture these being right angles. Sorry about the ink issue. Find BX. So you know what I'm going to do? A lot of people want to call this their variable. I'm going to just call this whole thing. So 3 root 2 is a leg. So leg squared equals the adjacent part times the whole, which is just x. This is why I'm doing this problem. So you apply this square to both. 3 squared is 9. Root 2 squared is 2. So 9 times 2 is 18. So clearly x equals 6. All right. There you go. That's you can do the rest and check the answers. These 2 rules here, this is huge. Huge.